Hello everyone, welcome back. Today we show the daily questions, a medium one that is zero array transformation 3. Um, uh, I think the first version of this problem had been solved in my previous video. This is the third version, so I don't know why the second versions, but let's focus on this problem. The statement give us that you given an average, okay. And each query represents four actions, decrease the value of each index in the range. Okay, the same statement as before, but there's another requirement that is return the maximum numbers of elements that can be removed from the queries, such as nums can still be converted to a zero array using the remaining queries. It wasn't written at all. It's different from the previous problem that we only need to figure out that these queries is available to make the nums array become zero. But now that is to find the maximum number of elements that can be removed from queries. At the same mean, it is the same as the minimum number of queries that make the nums array become zero. Okay, so now we can use the same method as previous. Okay, the constraint here is okay, the same at a million. Okay, let's take an example. For example, we have a nums array like this, and we had a set of queries like this, 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 this. Okay. For example, we have four queries like this, and let's see. We can use 1, 2, 3, 4. Use on. Okay. Okay. Now back to the problem here. We instead of find the maximum number of elements that can be removed, we can find the minimum number of elements that must be should be kept from queries, so that its metonyms become zero. And we can do it by using a technique we call it sweep line. We iterate each from left to right, and as we assume that if we add e, so the previous, like from 0 to e minus 1 is on 0. Okay, we must make all the element from previous position became 0 before. Okay, let's see. Okay, as a point, for example, like this, you ask a positions, and it's non-zero, so you must find some. For example, like this, we have 3, so we need to find at least three queries that contain this position, like this, this, or this. Okay, back to the one. So we need to find one. Let's see this. Okay, right, we need to use this. So we choose this and make it become 0, and this will become like 2. Okay, right, because we choose this segment, so we're gonna decrease element inside us if it's greater than 0. Okay, it become 2, and check this, we need to find more 2 queries that's maybe like this or this. Let me draw one more segment too, so like this, this segment. Okay, now we need to find 2, and we have 3 segments that contain the second position here, and what we need to choose in here we use a ready method, that's ready algorithm, and we choose the farthest, the farthest ending point. For example, like this, we should choose this element, we should choose this. Why? Because it's farthest, so this segment is longest. Okay, so it affect more element inside the nums array than the shorter one. That is, you can affect this and this, but if you choose something like this, you only affect the second and the third element, which is not optimal as long as possible, because we have the flexibility of choosing decrease by two independently for each index. Okay, so we should choose the furthest ending point if we have many segments to choose. Okay, so we choose this, and on the element here decrease by 1 to become 1, 0, and this is like 1. Okay, but we have still one remaining. We never choose one, but we have this and this 3 and 5, and we should choose what, we choose the farthest one, like this is, and decrease it to 0, and okay, it's complete. You can choose this, but it might not optimal as the farthest. Okay, I explained that the longer the segment is, the more chance, the higher chance we decrease it to 0 easier. Is ready method. Okay, so just implement it. Okay, the algorithm here is to sort all the query ascending, by whatever by the starting point. So we use a technique called sweep line to iterate from left to right from every position of the nums array, and we need to find exactly nums queries that contain this position. Okay, let's draw another example, like take for 3, 2, 1, 2, 2, 1. So we iterate. Okay, iterate by e, and we need to find one segment and choose the farthest. So if there are many segments like this, for example, how do we know what is the longest sub queries? That's it. We use a heap, a heap to store the ending position on the available queries, and use the max heap to retrieve the furthest ending position. So use a max heap here, max heap to store the ending position. Okay, so but we also need to know that if we iterate to like this E position, this I position, and how many segments are there affect this position. For example, if we have we have some segment like this. If we choose something like this, like this, and you ask this position at I, so we have 3 affect. This is the selected queries. So how do we know this position have how many selected queries here? That's why we need to store another heap, another space to store which queries are affected to current position. So like this, we have three. Okay, so but if we iterate to like this position, we lost 2. we must remove this two. How to do this fast? We can use a min heap. So if we store a min heap to store or let me go here for we need to use a math heap to store on available queries not static. We have not static the queries, and we use another main heap to store all static queries that affect queuing position. That's called I. Okay, because we need to delete on the main heap that store queries that's left I and right is y is queuing position, I is queuing position, and left and right is the range of this query. Okay, and min heap store queries static query start. Okay, yeah, so now just implement it. Priority queue. By default, a heap is the math heap. Priority queue is the math heap, and we need to create another main heap. Main heap. Set 0 for I for from left to right, but first we need to sort the queries by the beginning position, so we can do the sweep line technique. Okay, now we need to push on to like y J is the index of queries. J is less than queries size, and queries J like I okay 0 J0 is less than J0 means the left is less than I, so we must choose this, right? Okay, we push this to the math heap as available options. Choose one. So now we have I. That means it may contain or not. So only post it if queries J1 like is greater than I. So we post this into the array. Okay, and increase this. So we now have on the in the math heap we have on the segment card that may contain the E position. And now what we need to choose, like that is if we need to store another that is current what we call it cur. Okay, let's use cur as the number of query that affect to current index position. Okay, if cur is less than nums I. So we need to add more, right? We need to select more. Let's do the one here, and the size of the mass heap. Okay, we do some top if mass heap top, like if it is less than okay, right. So we choose the furthest point and choose, so select if mass top is less than current position, so we must not continue, right? Break. Must not continue because it only contain less than I position. That means not doesn't contain the E at the I position. So break it. Otherwise, chooses to the main heap here. Goes to the choose the pop and create out and put this to the selected one. Okay. What we do next here? Pop it out. Push the mass heap. Pop it out, and current is like plus, and we select this, so we plus the static here. Current here is okay. Current. Okay, some before that we should remove on the not affected in the selected one. If main heap, we store main heap here to fast erase on the element that less than I, so we should pop it out. Pop. Okay. So the curse is the mass heap. Okay, the mean heap size. Okay, the mean heap size means store static one. So now we got the answers is queries minus the static one minus the static queries. Push plus no. And top is less than I, so correct pop out. In this case, that's if main heap size is still less than num I, so it's not be 0 minus 1 because we didn't have a solution here. Okay, after we select it on, it's still unavailable. It's still less than the num, so we ignore it. Okay, accept it. As nowadays, maybe in today's problem is so hard to explain, but I hope you understand what I code here. I will try to improve day by day.